We'll start from where we finished yesterday. I rushed through this question a little bit. I will go through that again, like for the last CND again. So remember we assume in this question sine, cosine, tangent got restrict domain. So the domain what we can put into those three functions is only these values. And then we think about cosine. Okay, so first of all, it's a composite function. The inner domain must be a subset of the outer. Inner range must be a subset of the outer domain. So if we think about the domain of tan inverse, what's that? What's the domain of tan inverse? R, right? Or real. Like the range for tan is real, so the domain for R tan inverse will be real. So it doesn't matter what we have inside. Like it's also like always alright to put into the tan inverse function. So now let's think about what we can put in cos. So what's the domain for cos? What's the domain for cos? 0 to pi. We restrict because we also have the inverse function, so that's why we restrict it from 0 to pi, become a one-to-one function. So the domain for cos and the domain for this composite function will be 0 to pi. So what you can put in cos first is 0 to pi. Okay, so what's the range for the inner function? Range for cos negative 1 to 1. Okay, negative 1 to 1 is the range of the cos, okay, the range of the cos. And then we put this negative 1 to 1 into tan inverse. Okay, so that's what we get from the inner function. We put that into tan inverse. That becomes the domain of tan inverse. Even though tan inverse got domain of R, but the inner function cannot produce that many functions. I cannot produce like R for the tan inverse. So I can only have negative 1 to 1 as the domain of tan inverse for this question. So if we sketch a tan inverse graph, like this is the tan inverse graph. Okay, so if I put negative 1 to 1, now if I put this part of the function in, so when x equals to 1, what's the y value for tan inverse? Tan inverse 1 is pi on 4. And how about negative 1? Negative pi on 4. So the function I can produce out is only this red part of the graph because I don't have domain of R. I only have domain from negative 1 to 1. So the range for this function will only becomes minus pi on 4 to pi on 4. Okay, because I can't produce the rest of the domain. I only have negative 1 to 1. The range I can get out is only from negative pi on 4 to pi on 4. Okay, I can't produce anything else other than that. Okay, the full range for tan inverse should be negative pi on 2 to pi on 2. But because I don't have all the domains, I can't have those two, like the two sides. Okay. Let's have think about the next one. So first of all, let's think about what's the range. Like think about the range for 2 sine inverse x. What's the range for 2 sine inverse x? What's the range for sine inverse? Negative pi on 2 to pi on 2 and times that by 2. Negative pi to pi. Okay, can I put negative pi to pi into a cos function? What's the domain for cos? 0 to pi. So what happened? You need to restrict it. So a graph of two steeper, like this is the 2 sine inverse x function. This point will be 1 and pi, and this point will be negative 1 and pi. So times by 2. So stretch graph higher by 2. So I can't get from negative pi to pi. I can only get from 0 to pi. So from 0 to pi is here. So I can only take this part of the graph. Okay, I can only take this part of the graph. So the domain of x can only be restricted from 0 to 1. Okay, I can't have the -1 to 0, -1 to 0 part because that gives you a range of -pi to 0 and cannot put into a cosine function. Okay, so I want to make the innerst range become a subset of the outerst domain. So now if I have x belongs to 0 to 1, then 2 sine inverse x belongs to 0 to pi. And I can put 0 to pi into the cosine x. So what y value I can get if I put 0 to pi into cosine x? -1 to 1, right? 0 to pi for cosine x. So is -1 to 1. Okay, so the domain is 0 to 1 and the range is -1 to 1. Yes? Which one? Which one? Which one? This one? Yeah, so first of all, I think the function for this inverse. Okay. And then the range of this inverse function is -pi to pi, right? I times 2. I times the 2. Originally, sine inverse range is -power 2 to power 2. I times by 2. So that's the 2 sine inverse function. So it's -pi to pi. And because -pi to pi cannot put into 0 to pi here, so I only left half of it. So I only take domain from 0 to 1 to get the super range. So the super range is 0 to pi, put into cosine. Cosine get -1 to 1. Because that's the beginning restriction, because we are assuming all the functions suitable to find inverse function, and I must restrict it by the original like assumption, like we take this part of the graph, take this part of the graph. So because we have sine inverse, cosine inverse, tan inverse, so all of these functions this becomes to 1-to-1 function as well. So this is an assumption, it's not true, like cos domains are, but because we want to make inverse, so we in this question we restrict it in between those. All right, everyone, any questions for this exercise? All right. I think the most difficult one will be B. So if like I rushed through B yesterday, so if you have time later, get B. Think about B again by yourself, like next period. So B is the most important one. Again? Do you want me to go through that again? I can. Okay, so let's think about this again. I'll just clear all this writing here. Okay, let's think about B. So what's the domain for tan first? Let's think about outerst domain. What's the domain for tan x? Not inclusive, right? So minus power 2 to power 2. So what's the range for 2 sine inverse x? We just did that. What's the range for that? -pi to pi. Case is too big, like it's not a subset of the domain. So I need to restrict that function. So I will sketch in the function. So I'll sketch this 2 sine inverse x. You know that's a dilation by 2 from the x-axis. So that's 1 comma pi and -1 comma -pi. But the range is not good because the range, oh sorry, that's a square bracket. So I can take -pi to pi. But because I only want to restrict the range from negative, I want to make this become a subset of that. So my range needs to be the same as the domain of the outer function. So what I'll do is, this is -power 2. And this is power 2. Open circle here because I cannot take that point. Like -power 2 is a round bracket, so I cannot take that point. So the y value for 2 sine inverse x equals to power 2. sine inverse x equals to power 4. So what x equals to? X is sine power 4 and x is root 2 over 2. So this point is root 2 over 2. Yeah, this point is root 2 over 2. Then by symmetrical property, this point must be negative root 2 over 2. Okay, so that's this point. So the part I can take is this middle part here, this green part, which is like successful part. So the domain is actually here. So I cannot take from negative 1 to 1. I can only take from negative root 2 over 2 to root 2 over 2. So my x domain of the inner function also as the domain of the composite needs to be negative root 2 over 2 to root 2 over 2. Because I only can take this part to make the range becomes negative power 2 to power 2. And when you put negative power 2 to power 2 into tangent, what's the range? When you take negative power 2 to power 2 into tan, R. So y belongs to R. What's the tangent graph looks like? So negative power 2 is the asymptotes, power 2 is the asymptotes, and then a tangent graph looks like this. This is a tan graph. So range of sine inverse put in as the domain of the tangent, and then the domain of the tangent is negative power 2 to power 2. So I have full graph for tan for one cycle. So the range is R. Okay. Okay. Any other questions? Okay. If not, let's have a look for the last page first. I'll talk about example 13 first, and then back to the solving. Okay. So when you learn method, when you talk about maximum value and minimum value, what do you do? When you learn method, when we talk about, sorry, find the derivative and make it equals to 0. Anyone remember, like, there's one type of question is not very suitable to do derivative equals to 0. What kind of function is that? It's circular function. Think about why. Why I can't really make diff equals to 0 to find max and minimum? Multiple points. Okay, there's so many points to give derivative equals to 0, and it's not really good because you can have, like, say a function like this, and you have many points have derivative equals to 0, and it's only the local minimum and local maximum. It's not necessarily the absolute maximum and minimum, the global one. So circular functions to talk about the max and minimum values is not suitable using diff equals to 0 method. So what method we use in math method? What kind of ways we trying to find the maximum minimum value? Anyone remember? Put the graph into the calculator and see from the graph. Okay, that's the method we use at that time. Okay, let's think about this question here. So what I want to say here is I can't really use diff equals to 0 method to find the derivative equals to 0 and to find the max and minimum. It's very hard to do that in circular functions. Okay, so when you see circular functions and ask for maximum and minimum, 90% of the time you can't use the diff equals to 0 method. So in this question, I want to find the maximum value and minimum value of the following. So let's have a think about that. So if I give the name as y, so this function is y, I want to find the maximum value of y and find the minimum value of y. Okay, sine squared x plus 2 sine 2x plus 2. What kind of function is very close to quadratic? So if I let a become sine 2x, y will be a squared plus 2a plus 2. If you want to find max and minimum in quadratic, what kind of form do you need? Complete square, so turning point form. So y equals to a plus 1 squared minus 1, that's plus 1. Okay, so we have that. But if I just sketch this quadratic, so let's say this is y, this is a axis, have negative 1, 1 as my minimum point. Okay, that's my quadratic. So that point is negative 1, 1. Just look at this graph. I have minimum value, but I don't have maximum value. What's another restriction on A? What A must belongs to? Like A is what? A is sine to x. So A must be in between negative 1 to 1. Right? A is the solution for sine to x, and sine to x doesn't matter what x you take. The range is always negative 1 to 1. So A can only change between negative 1 to 1. Therefore, this is negative 1. This is 1. Only this part of the graph will exist. Like these parts do not exist because I don't have those values. My A cannot be those values. So when A equals to 1, what Y equals to? Not 2, 5. Okay, you sub A equals to 1 into the function and solve for Y. 1 plus 1 is 2, 2 squared is 4, 4 plus 1 is 5. So it's this red part of the graph. And the Y minimum equals to 1 and Y maximum equals to 5. It's very easy to see from this graph. So doesn't matter what is x, okay? I don't care what is x. But if it's a sine function, your range only in between minus 1 to 1. So the A value can only vary from negative 1 to 1. And then if I make function y in terms of A instead of x, I will have this function and only this red part of the graph will exist. So the minimum value is 1 and the maximum value is 5. So it's very easy to think about B then. What's the max and minimum for that? If I put that as a reciprocal. So max will be 1 and minimum will be 105. So the 1 over the max will give you the minimum and 1 over the minimum will give you the maximum. So if you know the max and minimum for the top function, you will know maximum and minimum for this reciprocal function here. Okay, so that's a really interesting question. I think I find it in textbook, so I put it here to show you that. And lastly, we'll go back to a circular function question. Okay, I have 5 questions here. You pick one and we go through one examples. You pick one. A, B, C, D, E. Which one you want me to go through? E. Okay, I'll go both D and E, okay? I'll do D first. Okay. For the A, B, C, you just need to make the reciprocal, like cosec becomes 1 over sine and solve for sine function, and cot make 1 over tan, solve for tangent function. So whatever you solved before, you solve the same way. You just need one more step to make it the reciprocal function first. So if you think about D, the first thing is I need the x to be the bracket to have the same number of x or same kind of expressions. So how I can make cosine 4x in terms of sine x? Which one you use? Okay, there's a cosine square minus sine square. There's 1 minus 2 sine square, and there's 2 cos square minus 1. 2 cos square minus 1. So what that will becomes? 2 cos squared, how many x? 2x minus 1 equals to cos 2x. Let's think it up. Why? I still don't understand why it's always like that. Okay, it's here. That equals to cos 2x. I don't really like to see things in this way, so I always let A equals to cos squared 2x. I have a question. No, cos 2x. So what's your A belongs to? What A belongs to? Negative 1 to 1. Okay, range of cos is negative 1 to 1. So your value, when you solve out A, your A must be in between this range. So I have 2A squared minus 1 equals to A. You won't always need to use that range, okay? So, but like I put there in case, okay? In case, like if sometimes I solve out the value of 2, like I don't really need that value. So 2a squared minus a minus 1 equals to 0. 1, 2, 1, 1 minus 1. So it's minus 2 and 1. That gives me a minus 1. So it's a minus 1 and 2a plus 1 equals to 0. So a equals to 1 or a equals to minus half. I want to solve in between 0 to 2 pi. So I'm not sure which way you use like last year method to solve circular functions. I'll have cosine 2x equals to 1 and cosine 2x equals to negative a half. So cosine what equals to 1? If it's 1 or negative 1, that's the highest and lowest value in one cycle. So there's only one value gives you maximum or minimum in one cycle. So you don't need to give two base angles. So cosine what equals to 1? Cosine what equals to 1? 0. So 2x equals to 0. So x equals to 0. That's only one period. And what's the period of these two functions? What's the period? What's the period for cos? 2 pi over 2, that equals to pi. So when you have 0, well, you can't minus anything because you're out of the domain, but you can add pi and add pi. So you have 0, pi, and 2 pi. Okay? Cosine negative a half. Okay, cosine what equals to negative a half? Negative a half is not 1 or negative 1. So I need to think about two values give me cosine negative a half. So which two quadrant it must be? 2 and 3. So this one and this one. So cosine what gives you a half? Cosine what gives you a half? Pi 3. Okay, so then in second quadrant and third quadrant, it will be those two values. And it will be 2 pi over 3, and then this one will be 4 pi over 3. Well, I know someone used plus minus 2 pi over 3. I don't really like to use that. Well, it doesn't matter, you get the same value in the end. But think about that. If you take the negative, it's out of the domain. You need to add things on to get the next value. So I will just take the positive. So it's 2 pi over 3 and 4 pi over 3. So 2x equals to 2 pi over 3 and 4 pi over 3. Okay, so it will give negative and give reference angle of pi 3. So x will be pi over 3 and 2 pi over 3. Obviously, I can't minus pi from those two values. It will go out of 0. So I'll add pi on it. So if you add pi on that, that's 4 pi over 3. And this one will be at a pi is 5 pi over 3. Can I add another pi? 2 pi is the restriction. No, like if you add another pi and add a pi of 3, that's definitely out of 2 pi. So the 4 values I have is those 4 values and plus those 3 values. That's the solution to this question. Okay, so you can put them in order, like x equals to 0, pi of 3, 2 pi over 3, 4 pi over 3, pi, 4 pi over 3, 5 pi over 3, and 2 pi. Okay, so the final solution is x equals to 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, and pi. What's the pattern? What's the pattern for this sequence? Like 0, pi over 3, 2 pi over 3, pi. They're adding what? Pi over 3. So I can say x equals to pi over 3k, where k belongs to 0, 1, 2, 3, dot, 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 until 2 pi, that's 2 pi until 6. Okay, so that's like follow that sequence. And you don't need that, you don't need the last line. I just say you can see from that. Okay, for the next one, what kind of form I need to change? I need to change left hand side or right hand side. Okay, which formula I should use for left hand side? Again, 1. So I can say that's cos 2 times x over 2, right? So it's the double angle formula. I can use the 1 minus 2 sine square x over 2 1 because I need sine in the end. So I want to make them all become the same variable. So I have 1 minus 2a squared equals to a. 2a squared plus a minus 1 equals to 0. 1, 2, 1 minus 1. 2 minus 1 is 1. So it's a plus 1, 2a minus 1. So a is minus 1 or a is half. Sine x over 2 equals to minus 1. Sine x over 2 equals to half. What's the period? 4 pi. 2 pi over half. That's 4 pi. Okay, so 4 pi. Okay, again, sine what equals to negative 1? 3 pi on 2. I only need one value because that's a minimum. So that's 3 pi over 2. X equals to 3 pi. Can I solve out any, well, is that in the domain first? No. Okay, if I plus 4 pi, definitely not. Minus 4 pi? No, so I don't have solution for this equation because it's out of the domain. Okay, sine what equals to half? Pound 6 is one value. What's the other one? 5 pound 6. Okay, so x over 2 equals to pound 6 or x over 2 equals to 5 pound 6. So x equals to pi over 3 or x equals to 5 pi over 3. Can I add or subtract domain period on that? No, it's out of 4 pi is too large. So the only two solutions we have is those two. I only have two solutions here. All right, everyone, that's the end of this chapter. You can do revisions, and next period is just study period. If you have any questions, just let me know.